completed, the dam will be 1.3 miles long and 610 feet high. That's just as long and twice as high as the Golden Gate Bridge. Positioned on the Yangtze, 1,200 miles upstream from the great port city of Shanghai, the dam will act as a plug. It will control the river where it narrows through a series of canyons called the Three Gorges. The man in charge of this massive project is one of the world's most brilliant and respected engineers, Mr. Liu Yumei.
它的上游修建一个水库。
In order to stop the floods in the lower Yangtze, we need to contain the water during high water periods in a man-made reservoir created by blocking the river with the Three Gorges Dam.
慢慢减弱了以后，然后它再慢慢的往下放。
We can then release the water from the reservoir in a controlled fashion to prevent flooding. This is the main reason we're building the dam, to prevent flooding.
But how do you go about building the world's biggest dam? First, you build foundations. By the time it's finished, enough rock will have been excavated to build 100 Empire State Buildings. At regular intervals, every day at the dam site, work stops as engineers arrive to position dynamite for blasting. Team leaders coordinate the blasting work. All workers know their red flag means a danger zone. Boxes of dynamite are thrown like footballs. But don't be fooled. These are Army-trained demolition experts who know the risks. Detonators are made by taping sticks of dynamite to a fuse, which will then set off big clusters of explosive. The red fuses and explosives are put in place according to the plan. Dynamite is most effective when drop-down holes drilled deep in the granite. At this stage, it would take just one slip to endanger not just lives, but the very foundations of the dam. It's dangerous and dirty work. And to stay alive, you need to know what you're doing. The blasting teams know when it's time to evacuate. The fallout from these explosions blackens the sky and fills the air with dust. In fact, each and every day, 15 tons of dust smothers the site. After the day's blasting is complete, workers remove the rubble. Most will be ground up and used in building the main wall of the dam. The rest will be sold to build highways for China's rapidly expanding infrastructure. But how does a dam really work? Daniel Beard is one of the world's leading experts on water technology and large dams. In 1993, he was appointed by President Clinton as Commissioner of the U.S. Bureau of Reclamation with a special task to investigate large dam building around the world.
We build dams across the river, and what that does is impound water behind the wall or the structure that's built, and then water is diverted either through the dam or around the dam through turbines to generate electric power, or water is held there to provide flood control for individuals downstream, or it's diverted through canals to to either cities or communities or to farms to provide water for irrigation or for drinking. The fascinating thing about large dams is that they take on a life of their own. They become symbols of a country's arrival as a first world nation or a developed nation. They become symbols of what is owed a people or a community. They become symbols of people's use of technology.
No one has ever built a dam this size before, and to do it, the Chinese are pushing at the very limits of dam building technology. For instance, how do you build a 610-foot wall in the middle of a river? The first step is to provide a dry base to build on. To achieve this, the river is diverted from its natural course into a new 300-yard wide channel, bypassing the main dam site. Throughout the main construction period, shipping will use this channel. The channel's wide enough to enable floodwater that may occur while the dam is being built to flow past the central structure without destroying it. As the diversion channel takes the main flow of water, the river's natural course will be gradually blocked by dumping rubble to form a temporary barrier called a cofferdam. A second cofferdam will then be built downstream of the first. Over the next 3 months, the water between the two cofferdams will be pumped out. This will leave a dry bed on which to build the foundations of the dam's main wall. This is one of the most dangerous phases of the whole construction process. Until their cement core has been built, the cofferdams are made of rubble, which is simply dumped into the river. At this stage, they are extremely unstable. Dump trucks work in an endless rotation to lengthen these temporary walls. The rubble is produced by the blasting. Soil removed from the riverbed loosely binds the rocks. Then pumps inject bentonite, a liquid clay and cement mixture, into a trench in the middle of the cofferdam. The bentonite takes a few days to dry out. Eventually, it hardens into a substance strong enough to form a backbone, which will prevent the cofferdam's collapse. When the liquid sets, it remains flexible enough to prevent the structure from cracking under pressure. Once the cofferdams are in place, the workers have to race against time and the weather to shore them up and make them secure. The consequences of the '98 flood would have been even more catastrophic if the cofferdams hadn't been secured. A collapsed cofferdam would have sent a huge tidal wave down the Yangtze, overwhelming everything in its path. Only when the cofferdams are completed and made safe will the water trapped between them be pumped out. The riverbed will then be dry and work can start in the dam's central section. In the meantime, the river still flows through the temporary diversion channel, and the cofferdams are nearly completed. On dry land, the north end section of the massive main dam wall has begun to take shape. The scale of this giant undertaking is formidable. 350 buckets of cement, each weighing 20 tons, are lifted into the main dam wall every 24 hours. The proportions used in mixing the cement have to be decided on scientifically, as local climatic conditions affect the drying rate. Get it wrong and disaster threatens. It takes 5 minutes to swing each giant bucket across the void to the top of the dam. Once there, it will be tipped into a preformed casing where it hardens into a block. One small piece of the dam falls into place. On this site, women as well as men are employed in some of the most skilled jobs, including crane operating. These are amongst the tallest cranes in the world. One crane is as high as the Victoria Falls in Africa. Operators have to take an elevator and then climb 400 feet just to get to work every day. As the operator swings the vast bucket of concrete, engineers below indicate the exact spot where it should be poured.
Can you tell me something about yourself?
Yes, my name is Fang Zhihui. I'm just over 40 years old.
How long have you been doing this job?
I started operating a crane in 1978. Since September last year, we've been operating right up here at this height. It's much higher than before, but it honestly doesn't scare me too much, the extra height. To tell you the truth, once you get used to heights, the extra weight doesn't count. It's all the same to me. Just a moment. I have to give it my full attention. It's really complicated up here. There are other cranes around and you have to be very careful to avoid collisions.
And her family are committed to living amid the noise and dirt of the construction site for the next 10 years. Alongside the dam site, a city of the future is being built to house the people who will maintain the dam when it's finished. There will be great cause for celebration if the dam is a success. The dam truly is taking shape in the heart of China. Immediately above the dam lie the three gorges that have given the dam its name. The three little gorges on one of the Yangtze's tributaries, the Danning River, were formed by movement of the Earth's crust some 40 million years ago. The Danning flows into the Yangtze, but while the water of the tributaries remains sweet and clear, the main Yangtze is one of the most polluted waterways on the planet. Coal is used to create 75% of China's energy. China is the world's largest producer and consumer of coal. Carbon emissions are damaging the environment. The Three Gorges area of the Yangtze, from Chongqing in the west to Wuhan in the east, is the heart of industrial China. Factories in the area generate a high level of acid rain that covers an area the size of Japan. China's leading cause of death is heart disease, helped by the burning of coal from steel smelters and rolling mills. Many such factories are on the banks of the river Yangtze. Dam Director Liu hopes that clean power generated by the hydroelectric plant at the dam will help to reduce this terrible toll.
Because of the reservoir that will be created behind the dam, the Yangtze will contain a lot more water, so providing for the generation of 18.2 million kilowatts of electricity.
It will be the largest power plant in the world, capable of supplying all the power needed by a city 4 times the size of Los Angeles. This vast hole will be the site of one of the power stations. Solid granite had to be blasted to make way for its foundations. By the time the dam is complete, over 78 million cubic yards of rock will have been shifted in this mammoth drill and blast operation. It is hoped that selling the power generated by the dam will both fuel China's boom and help the dam pay for itself. The way power is generated by a dam is explained by Daniel Beard.
Hydropower is electric power generated using the energy of falling water. There's only one law that you need to generate power, and that's the law of gravity. As long as we don't repeal gravity, water's going to flow downhill, and as it flows downhill, we capture it, divert it through a tunnel, and run it through a turbine, and as the turbine spins, it creates electricity. It can be an inexpensive way of generating power if you look just at the cost of the turbine, but it also is expensive when you look at the impact that a dam may have on the community or the environment.
Today, the Yangtze River gorges are one of the most beautiful spots on the planet. Every year, up to 17 million Chinese people explore the beauty of the Three Gorges area. And since President Nixon opened up China to the West in 1973, many American tourists come here each year to marvel at the area's spectacular. People come to see wildlife and traces of ancient cultures. Like this reconstruction of a walkway built above the river 2,000 years ago. They come to see aspects of China that have gone untouched for thousands of years in an area that's now changing fast. Every year, the Yangtze carries not just people, but also millions of tons of cargo. But soon, a 610-foot wall will block the river. How will all the shipping traffic cross the dam? The answer is not revolutionary in concept, but it is in scale. Here, the foundations of a ship elevator are being constructed. The elevator will be a vast steel box driven by a mechanism strong enough to lift the box with a 3,000-ton ship inside. The box will contain 13 feet of water, enough to keep a ship balanced. The whole mechanism will raise a ship the height of the dam in just 42 minutes. The elevator in the center of the picture will be very fast, but it will be very expensive to use and only smaller ships will fit in. So most of the river's traffic will use the second mechanism, one of the world's largest system of locks. The 5-level lock will enable 10,000-ton barges to cross the 610-foot barrier of the dam. That's like moving the Titanic over the Statue of Liberty in just 3 hours.
When I dance,